Break Fix's History of Motorsports series is brought to you in part by the International Motor Racing Research Center, as well as the Society of Automotive Historians, the Watkins Glen Area Chamber of Commerce, and the Argetsinger family.
How to Beat the Mercedes-Benz W196. An Alternative History Accelerates the Mid-Engine Revolution by Karl-Heinz Mertins. The new 2.5-liter formula of 1954 raised the bar for engineering excellence and cost of entry to the pinnacle of motor racing. With Mercedes-Benz leaving the shadows of World War II and becoming an accepted participant in motor racing again, the Grand Prix community had to anticipate a full-out effort of a new generation of silver arrows. Indeed, new standards were set with a series of W196 variants born out of vast corporate resources, supported by component suppliers like Continental, Bosch, and Esso. In this story, the imaginary Italian Unione Automobili, previously formed of national legacy manufacturers other than Fiat, takes on the role of Auto Union AG of the 1930s as an antagonist of Mercedes-Benz and promoter of the mid-engine layout. A probabilistic SWOT analysis reveals what it would take to beat the mighty opponent from Stuttgart. This is the start for a motley crew of Australian and Italian engineers led by Robert Eberan von Eberhorst to create a victorious challenger. The prescribed engine configuration is a compact V6 in homage to the Lancia brand. Breaking with Italian traditions, emphasis is put on chassis development where innovations in tires, brakes, and aerodynamics will provide decisive competitive advantages. Dr. Karl-Heinz Mertins holds degrees in mechanical engineering and a doctorate in mechatronics and engineering from the Technical University of Berlin, Germany. In more than 35 years of engineering and business experience in Europe and the US, Karl has focused on product innovation and new business incubation, applying cross-disciplinary methods with cross-cultural considerations. His work included experimental work on intelligent mobile equipment and wind energy systems in multinational corporations and startups. His enthusiasm for F1 goes back to the 1961 season.
Like many people in racing, I'm bending the rules a little bit here, speaking to a society of historians. I will talk a little bit about the real history, but then veer off into an alternative history and give a picture of what could have been instead of what was. So the question is how to beat Mercedes-Benz at a time when it wasn't quite clear that they would enter the 2.5-liter Formula One race season in 1954, and so the model designation of W196 wasn't known yet, so it's kind of blanked out here in the title. Let me give you a timeline of where this all starts, and then I will talk a little bit about what happened here on the left side before we get to 51. In 51, and all this is somewhat relevant to the story that I will tell. In 51, Mercedes got back out of the destruction phase into the reconstruction and started building cars again. But not just any car. They started unveiling the 300 W186 as an internal code, and it was a challenger to Rolls-Royce, to Packard, if you want so. They wanted to really reestablish the company as a provider of luxurious cars and set the standard. Shortly thereafter, and this presentation happened at the Frankfurt Automobile Show in April, shortly thereafter, the board approved that the company should go back to racing. And there was a green light given for a sports car project first, the 300 SL, to ease into motorsports again after World War II. Now, what happened before here? There was, of course, the World War II, and before it ended, there were plans, particularly in the US, the Morgenthau plan, that foresaw that Germany should really be brought back to the Middle Ages and should have no industrial capabilities anymore. The facilities that had survived the World War should be dismantled or destroyed, and it should be an agrarian society that would go forward and not be a threat to mankind going forward. Well, that plan fortunately didn't come to pass. Instead, there was, of course, an activity, some of that on the table, and some of it was under the table. There were, of course, some of the Mercedes engineers that formed informal networks, and they were thinking about plans of what could they do and how could they survive and at some point go back to the former glories again. That happened, and that led to things like the Unimog, of course, a utility vehicle, kind of an agricultural tractor, and of course that kind of responded to the Morgenthau plan of focusing on agriculture and not on things like racing or luxury cars. And that machine was very successful. It was developed with very little means and with external help, and the Boehringer brothers chipped in, and there were other people that had allocations of sheet metal for milk cans and so forth, and they all contributed. Because at the time, in 1945, when the war was lost, Germany was under military rule, and the area around Stuttgart was ruled by the American administration then. And so material was scarce and had to be applied for, and to be a good reason as to why you wanted some material, and you couldn't ask for material for race cars, for example. Wouldn't have been a good proposition. Moves on from there pretty quickly. The Morgenthau plan gets replaced by the Marshall Plan. Money flows into Europe, and the reconstruction is pretty fast and furious. So there were some activities already at the beginning of 1951. A couple of the pre-war 164s were brought to Argentina to run in Buenos Aires at a couple of races. And the idea was, well, we were so successful with those pre-war silver arrows, we could probably just dust them off and use them again in this new age. It turned out they were not that successful. Neubauer was the moving force behind all this. He had a delegation going to Argentina with these cars. Engineer responsible for those, Uhlenhaut, was not in the delegation. So things were probably not perfectly set up, but those cars, 3-liter Mercedes, were beaten by 2-liter Ferraris, and it was kind of a shameful event from a Mercedes perspective, because the DNA of the company was indeed you make the best cars you can make, and when you go racing, you go for the win. You're not settling for second places. They had to rethink this whole operation and scale back a little bit, go back to building a sports car, and focus only once the dust settled and it became clear how Formula One would be organized in the future, that there would be indeed a new one, a formula that would give preference to naturally aspirated engines, and it would start in 1954. It became clear now that was the new goal for Mercedes. But in the interim, they were working on a race car that they could build out of this luxury car. Kind of a clumsy way to do it, but nevertheless, it turned out to be quite successful. Around the same time, at the end of 1951, Alfa Romeo, who had had 2 very successful years with the Alfettas, decided that that wouldn't be a long-term proposition. Going forward with those cars, they were at the end of their development potential, and you couldn't increase the compression ratios and the supercharger pressures and so on, and you couldn't deal with the fuel consumption that increased exponentially. So they abandoned racing completely. Now, if you are a competitor in this Grand Prix racing scene and you think about, well, I have to compete with Mercedes. Again, they're not doing things half-baked. You have to have the financial strength and you have to have the intellectual strength to build a true competitor, a good car that can indeed meet and beat Mercedes-Benz. It takes something. So here's where I veer off into La La Land, if you want so. During 1952, where could a group come about that would make a challenger for Mercedes? Not in France, I think. You know, the CTA Arsenal was a rolling disaster and would not have yielded a real competitor. In England, BRM was a bureaucratic mess and it wasn't really going anywhere fast. And it was also too much looking backwards to the 1930s technology-wise. So I could see a scenario in Italy. If you reconstruct something like the Auto Union, that had been very successful in Germany and had provided this competitive product to Mercedes in form of the mid-engine silver arrows that were initially designed by Ferdinand Porsche and his engineering office, and then Auto Union and Horsch in particular insourced more and more of that activity. So I suggest something like this, an Unione Automobili should happen in northern Italy. And it would be where Auto Union in Germany was pretty much mandated by the banks that they had to support the capital. In Italy, the IRI, the state holding, to which Alfa Romeo already belonged, would be a good vehicle to provide some serious competition to Fiat, which totally dominated the Italian auto scene, volume-wise and value-wise. Something needed to be done because, frankly, I think people with some foresight knew that companies like Lancia and Alfa Romeo by themselves couldn't survive long-term. Hindsight tells us that they didn't. But we're back in 1951-ish, 2-ish. This could have happened. We could have had a conglomerate of different brands that would cover different segments in the marketplace. They could even have a foreign branch in France. Panhard would be a good candidate. In those days, you couldn't trade easily across country boundaries. So Fiat had Simca in France. We would have Panhard, and we would have a luxury segment where Lancia would play a big role. Isotta Fraschini would also be integrated. The name rights would be acquired, and you would establish the luxury and the top end of the range with that brand. There would be an entry also in terms of two-wheel vehicles, and the scooter, a pretty rugged scooter from ISO, was available. So we have already the low-cost entry brand ISO Autoveicoli that makes the Isetta, and they also made the scooter, so we cover that. And also, in addition, goes back to last year's presentation, we also have a branch that deals with ag tractors because that helps develop the Mezzogiorno region in Italy, and that's one of the motivators why IRI will support this whole effort. This whole effort needs also to be joined by Pirelli, which has an interest in promoting their tires, and altogether this could be a competitor, or could be the financial resource, intellectual resource to provide a real competitor to Mercedes. So we have a few individuals here that will constitute the core team. But the head would be Robert Eberan von Eberhorst, who had ample experience in mid-engine cars at Auto Union before the war. After the war, he was involved in the Cisitalia 360, which also was designed and outsourced and relocated team of Porsche engineering. Ferdinand Porsche was incarcerated at the time in France, but his son and some of the old team members were working there. I put here Livio Nicolis as kind of the project manager in place as the right hand of Eberan Eberhorst, who was certainly the intellectual mastermind, but not necessarily involved in all the nitty-gritty. So Nicolis will take care of that. He has experience at the Alfetta program, and we bring in different generations. I think from my own professional experience, I think it's always very helpful when you have multiple generations on a team, not just an inbred group, so to speak, of graybeards. You need some of them, but you don't want to have the whole team of them. So we recruit, and those are real people, of course, as you know, Carlo Chitti and Giotto Bizzarini. Both are already at Alfa Romeo. It makes sense to rely on them a lot for chassis and for development and test and so on. They're enthused, and they come, very importantly, from the University of Pisa. So they have, at least in Carlo Chitti's case, a degree in aeronautical engineering. And we'll see later on that taking license from or learning from aeronautical designs and skills and technologies makes a lot of sense when you want to build a world-beater race car. On the engine side, we lean more on the Lancia personnel. There is, of course, Francesco de Virgilio, who pretty much developed the V6 engine at Lancia, the principles at least, the angle of 60 degrees. It goes back to him. He analyzed the dynamics of various V angles, and when you look at the history of Lancia, then you know they experimented with everything from 11 degrees downwards or upwards. And 60 degrees is obviously the ideal, but there's also a solution with 120 degrees later on. De Virgilio found that already in the 1940s. So he's obviously a member of the team. Then Taccone Mina is maybe a more practical engine designer who can detail an engine more, and he has shown that already as a long-term Lancia engineer. I couldn't get any biographic information on him. Maybe that's where some librarians can help me in the future. And then, of course, this fellow here, we'll learn more about him, Josef Mickel, who retired in 1950 from the Porsche engineering team. We'll rehire him as a consultant because he's a specialist in aerodynamics, and we understand aerodynamics will play a big role if we want to beat Mercedes. And it's also important to work very closely with the tire manufacturer. So we want to have somebody, I'm not particular about the name, from Pirelli, from the tire partner, because the suspension layout and design will have to be very closely coordinated with the tire capabilities. And so you want to have the tire people on your side. It's one of the lessons also from the Silver Aero pre-World War II, where Mercedes worked very closely with Continental, and that was very helpful to them. Porsche and Auto Union were not quite as engaged with Continental, and it was to their detriment sometimes. So the first task of this newly formed team was, before you start designing anything, go by this ancient wisdom here. If you know your enemy and you know yourself, you need not fear the result of 100 battles. So find out as much as possible about Mercedes. Where are they going? What can you expect from them? Rather than focusing just on your own thoughts and say, we know best how to build the best race car. Anticipate what your enemy or your competitor will do, and then not copy them. The goal is not to copy them. You cannot out Mercedes. If you try, it's a losing battle. You have to do something. You have to look for unfair, quote unquote, advantages. And you have to do something different. For example, mid-engine layout as opposed to what is most likely Mercedes' solution, the front engine. And then, as mentioned before, aeronautics holds a lot of nuggets of wisdom and a lot of technology pieces you want to adopt. So you want to send out people like Carlo Chitti to snoop around what's going on in aeronautics and at the universities that still teach that. There wasn't too much actual building and designing going on after World War II because of restrictions by the Allied forces. So what can you expect reasonably from Mercedes-Benz? Well, we know the company wanted and did indeed recover from the ashes. There was a lot of rebuilding going on because Mercedes had a very loyal workforce, and a lot of people that had survived World War II went back to remove some of the rubbles and to secure some of the machinery and repair it and improve on it. It's pretty obvious that Uhlenhaut and Neubauer will stay engaged. Neubauer already in his 60s, you can imagine, tend to relive the old days, the glory days of 30s, and that's why he pushed for this early engagement in Buenos Aires in 51, because he thought, hey, we have the goods still here, and why don't we just refresh a little bit what we had been successful with. I think Rudolf Uhlenhaut, by his nature, was more interested in a clean sheet design and be more in the times then rather than looking backward. What you know about Mercedes is they are very methodical in their development. They're not just going from the drawing board quickly to the foundry and to the machine shop and then assemble and go to the racetrack. That's not their way of doing things. They will work on components, test the components to death, assemble the components to subsystems, test again in the lab the systems and subsystems to death, When that all works out, then they have a car, and then they will also test it first on a lab with a rolling surface. And before they ever hit the tracks, they will know a lot about the vehicle and its capabilities, and then they will go out to the track finally, and then there's only small modification necessary, some tune-ups. And this leads to a situation. This is one of my rocking horses here that I like to think about and talk about, and that's the evolution strategy as it applies to technical systems and developments. The speed of progress, you can say, it depends on the mutation size. How much do you change? You start typically with some known platform, state of the art. And if you do very little, there's practically no progress. If you move on, you get onto a pretty steep curve of rapid progress. And there's a certain window within you can operate. If you're too low here with too small steps of improvement, you're not accomplishing much. If you're going overboard, you end up here. You end up in a Cisitalia situation, or in Monaco Trossi comes to mind, in a pre-war design of a Grand Prix car, which was basically an airplane without wings. There was a radial engine at the front. It was hanging over the front axle, and mass distribution was something like 70% front and 30% rear, which is a recipe for disaster, of course. You don't have to be a specialist in engineering to see that. So that was a design that fell somewhere into this part of the evolution window. Clearly overshot. You want to avoid that. Mercedes was more in this conservative pioneering mode. Some people have characterized the company as conservative pioneers. They're going for progress. One example would be that we learn in real history later on, they go from carburetors to fuel injection, and it's an incremental improvement, but it's one that's solid, and it brings some progress. It's very measurable. But they wouldn't go completely to a rotary engine or something right off the bat. There will be a tight budget. Don't expect any state subsidies or payments directly or indirectly, because Germany didn't have much surplus to throw around. They've hardly been able to cover the basics. But there would be technical inputs, of course, from suppliers that Mercedes had a tradition working with, like Bosch, Continental, and then Esso, the fuel supplier, was important too, because the fuel in those days was free. Formula didn't prescribe commercially available gasoline. You could brew your own mix, which they certainly did. And then there was, of course, the engineering force within the corporation. You could always ring up a colleague or meet over lunch and get some inputs and so on. So there was quite a bit of intellectual property and capability there. Now, Mercedes obviously lost the local nemesis, Auto Union. There was no chance that Auto Union would get back to racing. They hardly survived, and they were cut into two pieces, one in East Germany, one in West Germany, or one in the Soviet zone, the other one in the American zone. So there was no chance for that. So when they did something, it would have to have some benefit for their series production side of the business. And so it's very likely, very probable, that they would stick to the front engine, because all their commercial products would be front engine. Taking a little dive via Edmund Rumpler in the 1920s, the Mercedes or the Benz RH Tropfenwagen, but that didn't last very long, and so very unlikely that they would make a jump that would, to them, look like going potentially here down the drain. They would probably hang on to the swing axles or pendulum axles, because that was also their bread and butter product. Now, one would expect that they would modify this thing a little bit, because we know swing axles, and we'll get to that in a moment, are not the cat's meow for good road holding. So a case in point for all this, looking more toward what they have and what they want to commercialize, is the W194 project, this 300 SL, first generation. That's an excellent model to study here for this case, for this question that we have in front of us. Here you see this Adenauer, the 300 representative car, and very luxurious and expensive, and a dream car, for most Germans. It was totally unobtainium, and yet it showed, we're back again. And that would be the basis for this sports car that would go race. So they had an engine, and they had to live with this engine, because unlike Italians, they didn't jump right into making 5 different engines very quickly. They stuck with the block and with what they had to work with rather than tooling up very quickly. I'm amazed, and some people have written with amazement and with appreciation, that Lancia, for example, designed 25 engines in 5 years, which was nuts for a small company like that. Mercedes had this one engine, which was already an overhead camshaft engine, so a good start, but it was heavy. A boat anchor, if you want. So it had to be augmented with other designs that were within the realm of possibility, and one was obviously aerodynamics. And that brings me to this image here, because in 1939, when the Italians, when they thought they were smart in prescribing that the Grand Prix of Tripoli was for Voiturette cars instead of regular Grand Prix cars, they thought, well, now our Alfettas will have a good chance to win this race. Mercedes, at that time, when they still had deep pockets, designed the purpose-built W165 and sent 2 cars to Tripoli and ended up 1-2. But during qualification, they had to learn the bitter lesson that a 4-cylinder Maserati with a streamlined bodywork got the pole position. It was faster than the Mercedes cars. Unexpected in a way, because the engine was clearly inferior. So I think they must have gotten a bit of a lesson there that, hey, we have to look at the drag reduction and so on. Also, again, to study subsystems. And obviously, Rudolf Uhlenhaus came up with the space frame concept, the very light frame, to offset the high weight of the engine, but it was an unknown quantity, and not many people had built these types of delicate space frames. So they built a very quick mule car to test this concept early on, before they ever went too far down the pike, and designed this final 300 SL. Super leicht. But they did. And then to reduce the drag coefficient and to reduce the frontal area, they angled or tilted the engine at about 55 degrees from horizontal to simply reduce the hood height and thereby increase their speed. And here you can see Charles Faroux and Alfred Neubauer looking into the engine bay of that final product at Le Mans. So continued lessons to be learned from this. First of all, you learn Mercedes, they don't go full bore out and design everything from scratch. On the other hand, they're willing to stretch the envelope, to design solutions, again, somewhat dictated, of course, by the space frame. Want to have a deep door sill and threshold. They came up with the first iteration of the gull-wing doors that just reached down to the lower edge of the window, and you had to kind of wiggle yourself into the driver's. When they first got to the Mille Miglia in '52 with this car, the inspectors were a little bit leery to accept that as doors, and so it was a test for the subsequent Le Mans race, and I think they got into the Mille Miglia with this type of door, quote unquote. Later on for Le Mans, they changed it to the gull-wing doors as we know them today, and that was in reaction to and knowing that they would meet less leniency with the French authorities than with the Italian authorities, of course, in those years. We're talking 1952. They also experimented with something that was a little bit out of the ordinary, and a little bit advanced, or too advanced for Mercedes, one could say. It's this aerodynamic brake system. Some people will argue that was mostly shown during the time trials to confuse, irritate competitors. It was never meant to be really used in racing, because it was a little flimsy, and it was taken down before the race began. But we also learned from this development that Mercedes was willing to accept imperfections. For example, when you look at the engine compartment, it has no ventilation. There is no way to get the air out in an ordinary or in a very optimized way where you help reduce overall drag. They fixed that later on by having some openings here at the side, but not in this first generation of the 300 SL. So that was one, and then they stuck to this somewhat questionable dual pendulum rear suspension. Nevertheless, they were victorious in Le Mans, and then particularly at the Carrera Panamericana, which was quite an achievement for something that was built from bits and pieces that were originally meant for a luxurious car. Working, on the other hand, what we learned from there for the Unione Automobili team is we prefer chassis over engine power. Italians typically were interested in, for Ferrari in particular, the race car was a big engine, very powerful, and the rest was just a means to move forward. Chassis was never really his preference, in those days at least. In this case, our team will think differently and will work with Pirelli closely to introduce the Radial tires, which Pirelli had developed at that time, not for racing, but for passenger car applications, sports car applications, Cinturato C67, and we add on a competizione version of that tire. We'll use it for our dream car here. Of course, that also means the driving style has to be adapted to that. It's not totally easy for people who grew up with cross-applied tires. They have some difficulties, and that will require also very methodical testing. Let's look at other components that are important. The chassis frame itself is very important because you want to have a very stiff chassis, and the flexibility has to be in the suspension system and not like in leather frames where the frame itself was the spring system for most parts. So we have some lessons to learn from Cisitalia, for example, but this Porsche design, very strangely, has this space frame, but it doesn't make use of triangulation. You don't see that any of these square gaps are broken up with some triangulation. Very strange. I'm not sure what their motive was, because they were not under weight restrictions really. To me, that seems like a half-baked solution, knowing the quality of the engineers that were involved. Alfa Romeo, with the Alfetta, particularly when they ran to the end of its usefulness and modified it to the 159, which had the Didion rear axle, had also, at least some specimens, had this additional framework here. So you see the original ladder frame oval profile here, and then you can see they already made some augmentation, added basically an upper girder and did the reinforcement between the two girders quite well. But that was only a partial solution because it didn't have any lateral connection really, but it was better than nothing. What makes more sense is a true 3D space frame, as you can see in some of the airplanes of the time. That's where one of our references to aviation comes in, the space frame of a Boeing Stearman plane, which was a training plane for the most part. It gives us a good idea of spatial triangulation of the frame. Then, of course, we can even go further, but this is one bridge too far, I would argue, for race car designers. You could use the geodesic fuselage of British airplanes. Were successful in World War II and were very immune against partial destruction. They could take a lot of damage and could still go back to the base. You see some spinal framework here that is then cladded by aluminum or fabric or whatever the material of choice was. This is a little bit too much for a race car. It's also not as easily scaled down from the airplane size to the car size. So this is a more likely and more successful solution. This could be a foreshadowing of monocoque structures, but again, that's one or two bridges too far for the time. Keep in mind, race car designers are also people, and they work and concern themselves about their daily lives and the continuation of their careers. So if they go too far away, it goes back to that evolution function. If they veer out too far from the known, they risk that they have a big failure. And having a big failure with something that's a traditional design is tolerable. You can always say, well, everybody else did something like that. If you risk and stick out your neck too much with something that's totally unique and it fails, everybody and their brother will say, well, you shouldn't have done that, right? Could be a career-modifying event. But we're talking about wheels and suspensions. Let's start with wheels first. State of the art were wire wheels, and particularly Burani was one of the favorite suppliers for that. But that was also a fairly flexible wheel, and it needed tuning and adjusting and maintenance. Cooper, early on, after World War II, changed over to cast electron wheels. And part of the reason was that it was easier to get aluminum and magnesium in England after World War II than steel. Steel was rationed, and a lot of aluminum was found from war efforts and equipment. So that was one thing. And it was also good for Cooper's spare part business because it was an OEM wheel that couldn't easily be replaced by something else. But more importantly, in the US, Hellebrand had introduced already and proven the magnesium cast wheels machined then to fit, and they had won the 1952 Indy 500, and it became commonplace. So I'm wondering why people in Europe didn't look at those developments and said, there is an advantage here. We save some unsprung weight and we get a more rigid product. And it's obviously proven on high-speed ovals. And then let's look at suspension systems quickly. Lancia had already introduced with the first generation of the Aurelia a semi-trailing independent rear suspension, which you can see a top view of here. It would be a coil spring and the attachment points to the chassis, and it's the drive shaft, the wheel. So this would be a start, we think, for development for an optimized rear wheel suspension, independent suspension for a race car. It has its pros and cons as well, but you can play a lot with the different angles and orientations of components. You can do that in 3D and get some reductions in toe-in and in camber change with the spring deflection. So there's probably something to be found. Now, we assume that Mercedes will stick with the pendulum axles, maybe in this format, but it's the one that gives you the highest roll center, and that's not very popular really for race cars. You can really get to the point where you jack up the one wheel and it leads to instabilities. You have pretty steep camber angle changes. It's not the best thing for a race car, so we assume that Mercedes will modify that. You tried to make the pendulum lengths as long as possible, so you could do something that goes underneath, could even to the opposite side, and you could crisscross the links there. So I would expect there, putting myself into 1952, that Mercedes would work on some of this stuff. And what we see here is an interesting car from New Zealand, and it dovetails quite well with people that came back from World War II, had aircraft experience, were aircraft mechanics. A couple of folks in New Zealand built their own car. They had studied and read about the Auto Union mid-engine configuration, and they said, we can build that too, and we can go to the scrapyard or to the auction places where you can buy cheaply surplus from the Army and from the Air Force, and that's what they did. So they built their own interesting car, and it had a very low pivot swing axle arrangement, which is shown here in a picture of the renovated or restored version of this car here. This looks almost like it's over restored, but it's interesting. You see very long arms of this swing axle. They almost merge to a single axis of rotation down here, very low. And they also pilfered some oleo struts from airplanes and used them as a spring and damper. Very innovative, a very interesting car. Not too much is known about this RA4 Vanguard, which worked with a four-cylinder standard Vanguard engine, slightly supercharged, and it had 2088 cc. So it was a Formula Libre car and didn't qualify for Grand Prix, but it was pretty much only raced in New Zealand. But it has been restored in England, and it will come to a couple of events in Florida. One is Moda Miami, and the other is Amelia. So you will see, if you get there, you will see this car in real life, and can see more than from these pictures. But an interesting way that tinkerers worked on something that made a lot of sense, and they had a lot of fun with it. One of the mechanics was then the driver, and he managed to participate at Lady Wigram trophy runs for several years, with modest success. Brakes, of course, are important for the race car. What can you do there? Obviously, ventilated drum brakes were the industry standard, alpine processes were often used to bond strongly and have a low thermal resistance between the iron liners and the aluminum body with fins, different shapes of fins. But by 1952, disc brakes became already a possibility for race cars. And again, that's a technology that comes from airplanes. During World War II, a lot of airplanes, British, American, used already a form of disc brakes. And there were several manufacturers. Dunlop was one of them. Dunlop worked with Jaguar on sports cars and Girling with BRM and got that to science already. And then Tony Vanderwaal, who had already started his own activities with the thin wall special, said, I want also to have the latest technology in brakes. And he worked with Goodyear and got some disc brake systems there. But we can assume that that technology was off limits for Mercedes, because I cannot imagine that any of these companies, particularly Dunlop, that helped Jaguar, would also help Mercedes to beat the snot of Jaguar. I think that was off limits, and I think Mercedes understood that, and so they were working with these aerodynamic brakes that we saw already, this roof-mounted effort. And there's also a patent that was issued to Auto Union in 1941. Fortunately, that image didn't make it, but it's a German patent that was issued and that shows an aerodynamic brake, basically a wing that you can flip up with servo power from the engine and assist in braking. Probably tailored to those record trips that people made on the Autobahn, but it could be used in Grand Prix racing as well. There was nothing that would prohibit that. Anyway, that would be one way to get around the disc brake embargo that I would think was prevalent. The other thing is driver position is one thing, particularly with a front engine car, the typical bomber seat, where you sit pretty upright, like in an armchair or the chairs you're sitting on. The driver sits very upright and provides quite an obstacle to the aerodynamic profile. And fortunately, this picture came across here, and that is Otto Mate in what is called the Fetzenflieger. He raced this thing that was based on the Volkswagen 64 or Porsche 64 project, got one. He was an Austrian, so he was close to the Austrian Porsche office at the time. So he got one of these 64s, which they were intended for the Berlin-Rome long-distance race that never happened, if I recall that correctly. So he got that. And Otto Mate, you have to consider, had a pretty severe motorcycle accident, so his right arm was not useful to him, and he needed to be able to lean on the steering wheel when he changed gears. So he had a shifter on the left-hand side, and he leaned forward on the steering wheel to shift gears. So that was a bit of an aberration. He needed that kind of seating position. But you can see here, it's unfortunate. It's not the optimum solution when you have a rear engine, or mid-engine in our case. On the other hand, what we learned from aeronautics, and particularly from glider planes or sailplanes, there was a development going on at the Politecnicum in Turin in 1953. In particular, there was a new Centro di Volo a Vela that was founded, and it was kind of an operation in the corner of a lab first. But the team there wanted to change the whole composition of sailplanes, because in sailplanes they have no engine, obviously. You need to have a very low frontal profile. You need to have a very low drag coefficient. And what they introduced was a leaned backwards position of the pilot. It's almost a position like you find in or found then in the, say, the Lotus Grand Prix cars, particularly the monocoque versions. And they could also beef that up with some scientific investigations. I have the source given here, that there are optimum angles for body parts, and they're not 90 degrees, so the upright sitting position is not necessarily the best, particularly if you don't have to have high steering forces to work with, which was one of the reasons why people sat so upright, or why NASCAR drivers also hang on close to the steering wheel, at least in the past. But in the case of a car with mid-engine, there's not much load on the front axle, and so the steering effort is much lower. So you can get by with this more relaxed, leaned back sitting position. And it's now standard practice, of course, in sailplanes. But in 53, that was something that was pretty new. In fact, it was unheard of, and people were wondering, can the pilots do that? And they had some test flights, and they felt, hey, this is great, actually. And so we sent, of course, Carlo Kitty around different universities. Naturally, he has to go to Turin and to Milan and understand what's going on there. And so he comes across this, and the innovator and the young man who wants to make his place in the history comes across this and says, hey, why don't we experiment with that and reduce the frontal area of our Grand Prix car? And that goes on with engines also, quickly talking about different engine choices. It seems quite reasonable for the 2.5-liter formula. First of all, that he chose the naturally aspirated one and the supercharged version that was allowed at 750 cc. The penalty for supercharging was just too high. So you look at a 2.5-liter engine and you ask yourself, how many cylinders do you really need? Do you need 16 cylinders or 24 or 4? Maybe 6 is a good compromise. Very likely, because you can see Jaguar was very successful with their 6 cylinders. Mercedes had just proven with the 194 project that, hey, we can win races and championships with 6-cylinder engines. And of course, they had slanted at Mercedes their engine. That was brought to an even more dramatic effect in the Cummins diesel special of 1952 that participated in the Indy 500. And it was Freddie Cummins' desire to prove that diesel engines could be very successful in any application, including race cars. So he built this special car with a Watson chassis, elongated and modified in many ways. But he chose to tilt the engine practically by 90 degrees. So the crankshaft is about here, and this is the cylinder head. Now this was overhead valve engine, as I understand. It was turbocharged, and it was tilted for minimum frontal area. So you could think Mercedes should think about those lines as well. In our case here for Unione Automobili, we say, well, Lancia is really our flagship brand, and it relies on V6 engines to a great extent. Why don't we also make our racing engine just like, say, the D20 V6 at Lancia that they had already at a 60-degree cylinder angle? Makes good sense. It's a short engine. It allows more space for the reclined driver position. So let's do that. But maybe we should change the angle as De Virgilio had proposed. You can do that to 120 degrees to make a shallower engine. So I put in this image here, which, to be honest, is not from the time we're talking about. It's a more recent South African aircraft engine, and it's a 120-degree V6-cylinder engine. Just to show you what the form factor would look like, I think that would give a pretty optimal configuration for a mid-engine configuration that minimizes the frontal area and the drag coefficient. That's it. So we assume that Mercedes will do this and use an inline 6-cylinder, which we can't know at the time that was a wrong assumption. I can live with that. And fuel injection is almost inevitable. And the question is, can you even go as far as direct injection into the combustion chamber, or do you allow for an indirect injection ahead of the inlet valves? Mercedes obviously had some experience in the DB 601 aircraft engine of World War II with direct injection. And we know that Scherenberg, who was the engineer involved, was parked at the time still at a small company called Gutbrot until he got through his denazification process and then could join Mercedes again. Very likely that he would push for an adaptation of this kind of injection. On the other hand, Italy had quite a lot to offer in terms of indirect injection. Fellow Ottavio Fuscaldo had patented the application in 1937, a solution for a very smart electrical injection. Very much like most cars that we drive today have their injection system. No electronics, obviously, because that wasn't invented yet, but the basic makings were already there. And this thing raced in the Mille Miglia of 1940. There was an Alfa Romeo 2.5 liter 6C equipped with this type of injection system, and it ran on a mix of palm oil, I understand, and some other non-conventional fuel component, because that was when Italy was in this autarky mode and couldn't import a lot of mineral oil, and so it was a theme that fit into the landscape. And it demonstrated, and also in a Gilera motorbike, as I understand, that this system worked quite well. It got forgotten for quite some time, but you can see electromagnetic injection valves here, actuated and timed by a distributor system, very much like you time the ignition. So it was not a continuous injection like, say, the Hilborn system in the US would have been. So that's basically what we decide, or we leave it to the engineering team. Do they want to go with a speaker direct injection that they also have at their disposal within Alfa Romeo, or will they go with something like this indirect injection? So then we say our special sauce will be the emphasis on aerodynamics, and we want to create downforce. And we saw this picture of the T80 yesterday that was explained to us. You can see the fellow who was behind, Josef Mikl, who was behind the patent that you see figures from here. And you can see that he not only had the side wings, but he also had an elevated wing with end caps and all the makings of a modern aerodynamic concept. So we put all this together into a final product, and we think we can beat Mercedes on a good day. Not always, but on a good day.
Thank you, Karl. I think we have some questions.
My thing that strikes me always when you have these discussions, why wasn't this sort of analysis carried out then? It's fairly capable. Everything's there. Mm-hmm. So why was the contemporary thinking not along these lines? Because I know that it's just retroactively, but all that was available then.
Yeah, and I limit myself particularly to the availability of technology bits and pieces. In hindsight, it's very easy to throw in electronics, for example, which wasn't available then. But a good answer of that is, I think I mentioned it briefly, people want to survive in their organizations, right? And for example, if you're in IT, at least in the time when computers first came up, if you specified IBM computers, you were home free. It didn't matter that they were not as functional performance-wise. They may have had bad service whatsoever, but it was IBM. And so if you were issuing the purchase order for IBM computers, you survived easily even if things fell by the wayside. If you would have specified some more exotic, more powerful computer, and it would have given you difficulties, everybody points at you and says, "You Dummkopf, why did you do that? How could you do that?" So it's always safer to stay with the incumbent solutions, and it takes risk, it takes the right personalities to venture out a little bit. And with this evolution window, you have to be really careful not to go too far out and fail. So I think there's more incentive for playing it safe than being too daring. And there's a herd mentality. So if everybody uses Weber carburetors in racing, why should I do something different, right? But if you want to beat the other guy, as I mentioned, you cannot out Mercedes. Don't even try it. You have to do something different, and you have to take the risk and to be willing to risk. I think Eberan von Eberhorst had demonstrated it throughout his career that he was willing to do that.
Thank you, Karl.
Thank you.
This episode is brought to you in part by the International Motor Racing Research Center. Its charter is to collect, share, and preserve the history of motorsports, spanning continents, eras, and race series. The center's collection embodies the speed, drama, and camaraderie of amateur and professional motor racing throughout the world. The center welcomes serious researchers and casual fans alike to share stories of race drivers, race series, and race cars captured on their shelves and walls and brought to life through a regular calendar of public lectures and special events. To learn more about the center, Visit www.racingarchives.org. This episode is also brought to you by the Society of Automotive Historians. They encourage research into any aspect of automotive history. The SAH actively supports the compilation and preservation of papers, organizational records, print ephemera and images to safeguard, as well as to broaden and deepen the understanding of motorized wheeled land transportation through the modern age and into the future. For more information about the SAH, visit www.autohistory.org.
We hope you enjoyed another awesome episode of Break Fix Podcast, brought to you by Grand Prix Motorsports. If you'd like to be a guest on the show or get involved, be sure to follow us on all social media platforms at Grand Touring Motorsports. And if you'd like to learn more about the content of this episode, be sure to check out the follow-on article at gtmotorsports.org. We remain a commercial-free and no annual fees organization through our sponsors, but also through the generous support of our fans, families, and friends through Patreon. For as little as $2.50 a month, you can get access to more behind-the-scenes action, additional pit stop minisodes, and other VIP goodies, as well as keeping our team of creators fed on their strict diet of Fig Newtons, gummy bears, and Monster. So consider signing up for Patreon today at www.patreon.com/GT Motorsports. And remember, without you, none of this would be possible.